topics that's very important in IB has to do with errors and uncertainties. So I brought an exercise for you to understand a little bit about the difference. Let's say we have a pendulum and we are going to measure its period of oscillation. And we're going to say that we are going to measure the period, which is going to give us a period of 5 seconds. We also know that the error associated with the instrument that we're using is of 0.2 seconds. As you can see, that's a pretty big error. So let's learn in the first place how to calculate different types of error, percentual or absolute errors. In this case, we know that our measurement would be not really 0.5, but 0.5 plus minus 0.2 seconds, because that's our concern. Our measurement could be anywhere from 0.3 to 0.7 seconds. But we also have something called our percentual error. In our percentual error, what we have to do is transform this value and see what percentage is our error. Now this is very simple to do. All we have to do is use the rule of 3, where we say the following. 0.5, which is our full measurement, corresponds to 100%. And then we ask our uncertainty, which is 0.2, what percentage is that? This will give us a percentage of 40%. So now we can actually express our error as this, using an absolute uncertainty, or we can also express it in terms of percentage. So now we say our measurement is, in fact, 0.5 seconds, plus or minus now a 40% of our measurement. So this is the way to convert between absolute error and percentual error. Now let's make this a little bit harder. Let's say now that we decided to measure 20 swings of our pendulum. If we measure 20 swings of our pendulum and we get the following, we're going to get a period of 20 swings. Let's say, for the sake of it, this took 9.4 seconds. We know that the error associated with our measurement is, in fact, 0.2 seconds, because we're using the same chronometer. We're using the same instrument. Now, in this case, we have to ask ourselves, how does our error change when we have more measurements? Now, this error here is associated to all 20 measurements. So now this error should be divided for each measurement. So we can say now, this is for 20 measurements. In the case of one measurement, all we have to do is divide by 20 in both cases, because this error is split between all 20 measurements. So we're going to have 9.4 divided into 20. That's going to be 0.47 seconds. Whereas our error, also divided in 20, will be that of 0.01 seconds. Now if you notice here, we can express our period as 0.47 seconds now, instead of 0.5. With our error of 0.01 seconds. So this is a much lower error than we would get if we used only one swing of our pendulum. Let's calculate our percentual error in this case. So here we have our absolute error, which means that basically our measurements are between 0.46 to 0.48 seconds, much better than above, right? And once again, we use our rule of 3. In our rule of 3, we're going to say the following. 0.47, which is our total measurement, is our 100%. In the second case, we're going to say, okay, so our error now associated is 0.01. What percentage is that? If we put all of these into a calculator, we should get a value of approximately 2.13%. So now we say that our pendulum is not only plus minus 0.01 second of error, but we could also say and the following terms of percentage, that our swing is 0.47 seconds, plus minus an error of 2.13%. Now, if we look at percentual errors, which allow us to compare, we see here that our percentual error is approximately 2%, whereas when we use one swing, we're talking about 40%. Basically, it's roughly as if we divided in 20. Roughly. We still have to do the math. So when they ask, for instance, in some type of exercise, why would we measure 10 swings, 20 swings, and not one swing? The correct answer would be to reduce the error associated with it. Because in this case, we have an error of 0.2 associated with one swing, whereas here we have an error of 0.2 associated with 20 swings. So the error gets divided. So each swing would get a less amount of error.